Now I'm going to show you what these filters look like in Logic. Again, there are free parametric EQ plugins you can use in the same way. First, though, I'm going to create some white noise in Audacity. You'll need to do this for assignment 8. I go to the Generate menu, select Noise, and create white noise with an amplitude of 1 and a duration of 2 minutes. Then I can export the noise as a wave and import it to Logic or Soundation. I've imported my wave file into Logic and set the looper to loop some of my noise. In Logic, EQ is built into every track. To turn it on, simply double-click the EQ button under the Setting button. The channel EQ window has frequency on the X dimension and gain on the Y dimension. Notice that the frequency range goes from 20 to 20,000 Hz, while the gain can boost attenuate frequencies by up to 30 dB. The Analyzer button allows you to see the spectrum of the sound as it plays. Logic is an 8-band EQ, and you can turn the bands on and off by pressing them. For now, I'm only going to leave filters 1 and 8 on, which is the exact opposite of Logic's default. These filters are called passes or cuts. Filter 1 is a high-pass filter, which is a filter that passes higher frequencies and attenuates lower frequency components. This is why it can also be called a low-cut filter. Filter number 8 is a low-pass filter, which passes low-frequency components of signals while attenuating high frequencies, which is why it can also be called a high-cut filter. Notice, as you move the mouse, the numbers underneath the filter change. As can be expected from a parametric EQ, the numbers refer to frequency, gain, and Q. If you want to have more accurate control over your EQ, you can manipulate these numbers directly instead of drawing on the curves. The next two filters, number 2 and 7, are shelving filters. The low shelving EQ affects only the frequency range that follows. The low shelving EQ affects only the frequency range that falls below the selected frequency. The high shelving EQ affects only the frequency range above the selected frequency. The shelf shape gives a gentle roll-off as opposed to the more heavy-handed action of the low-cut filter. Notice that with the same frequency of 200, a gain of -24, and a Q of 10, the results are very different from filters 1 and 2. Notice also that Logic shows you the resultant curve of both filters combined when they are both on. Bands 3 through 6 are parametric Bell filters. This type of EQ is referred to as fully parametric, and this type of filter is good for general sound shaping when the tonal balance of a signal needs to be changed. If you decrease the master gain, you can pull individual frequencies out of noise by using a narrow Q. You need to decrease the gain because anytime you boost frequencies, you run the danger of clipping. Concentrate your efforts on the fully parametric EQ filters. As in most audio programs, if you find you need more bands, you can always add another channel EQ to the track. Go to the empty space, select EQ, channel EQ. Your ears are your greatest tool. Your auditory cortex has been analyzing sound since before you were born, and it's better than the most high-powered computer. Being biological, your cochlea can get fatigued, just like a muscle, so take breaks. At the University of Buffalo, we had a tambourine outside the studio with the words ear cleaner written on it. Another helpful tip is to compare your sound to the original as you're working. In Logic, you can bypass the EQ effect by pressing the Compare button. In other programs, you may need to undo the effect you put on or turn the effect off on the track. Don't be afraid to take risks. Just like writing music, audio engineering is a creative activity.